One of the great features of J-Edge is that it's an extruded product, so it's very straight. The tolerances on this are just absolutely phenomenal. Whereas the bent plate is typically a very wavy edge in and out of the building, introducing to whatever contractor is providing facade very high tolerances that they have to adjust for.
This system reminds me, of course, of Unistrut and all the flexibility that comes with Unistrut. I mean, it's the same thing here. And, you know, I think we're just scratching the surface of what can be done with this system.
That's the reason why concrete construction has kind of taken off in advance of steel construction, and that steel has just kind of been hanging back there. It's because of this, because it's so difficult to hang things off of.
Have you noticed on those projects where they have added the the extension of the upper leg, have you noticed any issues with that extension plate staying straight when it's welded to the top edge of the extrusion?
We haven't yet. I mean, it's it hasn't been seen that, you know, there's any problems with it. So, yeah.
Yeah, sometimes just the welding, if it's not done correctly, it'll just produce some waviness in the member.
Yeah, one of the great,
as I saw, they look straight as an arrow though, of the Waddell and Reed and the Shamrock project. Those, it looked like they had done those extensions and they look straight as can be.
Yeah, one of the neat things is it's all done, you know, it's very controlled in the shop.
Right.
So
Right.
you don't have the, yeah, and they're able to grind that all down and do it in a very controlled process. Yeah.
That's a pretty heavy duty slab right there. That looks like about a 10-inch slab they've got going on.
Yeah, I think that this one was a very deep one. If I remember right, I think it was like 9 inches. But
Yeah.
see, that's another thing. That's another issue. You don't have to have a super deep slab anymore, because a lot of that is for transferring loads
Right.
inside of the slab. And so this really kind of frees things up if, you know, the structural engineers will start to take advantage of it.
That almost looks in that photo like the extrusion is welded to the edge of the top flange rather than overlapping it. Is that what I'm seeing there?
Yes, it is. Actually, it's welded onto the top of the flange instead of overlapping it. And so this would be one of the standard ways, and they have an outrigger that they've welded on there too. It can be overlapping the top of the flange though. That's one of the, whenever we start to get out beyond that, that's whenever we have to have some other systems of support. And so we'd see outriggers out even beyond that. Very good questions. Are there any other questions for today?
These are all threaded, bolted connections associated with this system. Is there any way, or are they locking these nuts at all, or are they just tightening them down and letting them go? Is there anything they're putting on there to assure that the nuts don't loosen over time with the comings and goings of the facade and so on?
Yeah, there's provisions for installing either lock nuts or some locking mechanism.
Okay.
And it's based upon specification. Now, one of the things that we did, it's interesting for the Microsoft Office area, we actually created a slip critical connection. And what that means is it's designed to not slip during seismic events based upon the high tension capacity of this T-bolt. It's designed exactly like non-slip critical bolts in steel structures. And so it carries a load that is permanent tension across there, has a locking mechanism, and is able to create that surface compression enough to have that resistance laterally.
Interesting.
Whereas, with the typical embeds, you don't have a fang surface. it's malleable thin steel, and you don't have that capability of being able to create those types of connections.